there when the pyramids built at 2500 BC suggests that they're watching the stars very carefully because they're able to orient this narrow little shaft to those stars. So hard to imagine that they don't know it's moving, and it's moving because of precession. And then there's the famous zodiac of Dendera. The orientations within that zodiac demonstrate or are signaling earlier stages of Egyptian civilization. And yes, in Greek times, certainly precession was known, but why would they call attention to earlier stages within the precessional cycle in this much later temple if they didn't already know about precession?
While ancient structures suggest an earlier knowledge of precession, Western scholars generally credit the Greek astronomer Hipparchus with making the first systematic observations around 120 BC. Another Greek astronomer, Aristarchus, chronicled the movements of the Earth, Sun, and Moon. He proposed that the Earth revolves around the Sun almost 2,000 years before Copernicus did. Archimedes, the well-known mathematician and astronomer of the same era, taught the heliocentric theory of Aristarchus.
The fixed stars and the Sun remain unmoved. The Earth revolves around the Sun in the circumference of a circle, the Sun lying in the middle of the orbit.
Modern science, of course, confirms that the Sun is at the center of our solar system, but this knowledge was lost for almost 2 millennia, and the Earth was mistakenly thought to be at the center. This geocentric solar system was taught by Ptolemy and supported by the Roman Catholic Church for centuries. Ptolemy had to assume some wild movements of the planets to support his incorrect theory. He said they moved in epicycles. He could see the Sun rose in the east and set in the west, and proved that the Sun went around the Earth. What he did not realize was that another reference frame was at work. The Earth was spinning on its axis. Then, about 1,000 years after the pit of the Dark Ages, Polish astronomer Copernicus rediscovered what the Greeks had long forgotten, that the planets revolve around the Sun.
The interesting point was, it was lost approximately 1,000 years before the depths of Kali Yuga and brought back about 1,000 years after, which then shows this idea that what is lost, then it comes around again. And so these cycles just go on, these 24,000-year cycles.
When he wrote his paper explaining the solar system, Copernicus observed 3 motions of the Earth. The first motion is the Earth's daily spin on its axis. The second motion is the Earth's annual trek around the Sun. But he needed a third motion to explain precession. He used the term wobble or libration, assuming that only a wobbling Earth could cause us to see a different part of the constellations each year. Over 100 years later, Sir Isaac Newton applied his theories of gravity to the idea of a wobbling Earth. He determined that the Sun and Moon were the only things big enough and near enough to cause the wobble. This explanation of precession is known as the lunisolar theory. Another factor that might contribute to the wobble is the shape of the Earth.
If the Earth were a perfect sphere, there would be no precession, because there would be no way to apply that torque on the Earth. But since the Earth spins, it makes itself oblate by that spinning, so it has bulges on the equator. So this leads to a net force which would want to put the Earth upright. That's what the Earth doesn't allow it to do, but the Earth cannot completely escape that pull from the Moon, and instead of being positioned upright, it will shift the orientation of the axis. In other words, it will cause this precession.
This is the predominant theory among astronomers today. But in 1749, French astronomer Jean Le Rond d'Alembert found that Newton's lunisolar equations did not quite work, so he added variables for torque and inertia. Still today, lunisolar precession formulas continue to be adjusted, and some say they don't reflect physical reality.
according to the theory of lunar solar precession, if the axis of the Earth were to change relative to the Sun, this would have an effect on the seasons on the Earth. They would occur earlier or later, so we would notice variations, but this does not happen.
The seasons are caused by the tilted Earth revolving around the Sun. Any change in the tilt of the Earth, whether due to a massive meteor impact or the subtle wobble of lunisolar theory, would result in a change of seasons, even though our calendar would stay the same. Lunisolar precession theorists reconcile the regularity of our seasons by requiring the equinox to occur before the Earth completes its full 360-degree orbit around the Sun. But this solution contradicts lunar equations and observed eclipse cycles. Each answer merely creates a new question. Could there be an easier explanation of precession? Ancient scholars who observed precession of the equinox provided a simpler explanation than a wobbling Earth. They said that our Sun curves through space, moving in a great orbit of its own, pulling the Earth and other planets along with it. If the Earth did move along with the Sun on a curved path through space, we might see the same precession of the equinox through the zodiac and changing of the pole stars that the lunisolar wobble theory now attempts to explain. But it would not be caused by the Earth's wobbling independent of the Sun. It would be caused by the whole solar system curving through space. Another reference frame is at work.
We believe that our Sun moves in space with our entire solar system, that the axis of our Earth remains aligned to a point in space where that is fixed in respect to the equinoxes, it's fixed in respect to all the solstices, so that basically our entire system moves around a point in space. And this point in space, we believe, is a star.
A partner star to our own Sun? Some say the binary model confirms all of our celestial observations without the need for excessive torque or epicycle-type explanations. While the concept of a second Sun challenges our present understanding of the solar system, it is hardly a new idea. Some of the earliest astronomical records refer to the existence of dual suns. In fact, Mithraic beliefs were based on this concept.
There's one sun which is part of the planetary system, and there's one sun outside the solar system. And this allows Mithras to both be the sun, Mithras Sol Invictus, Mithras the unconquerable sun, and also seem to be operating for the sun or on behalf of the sun.
The yogis of ancient India accepted the binary model as a matter of fact, and also mentioned